If you add together sort of the three kinds of things that occupy the universe, the familiar matter, that's what we're made of and what our telescopes detect. The dark matter, that's the source of 85% of all the gravity we see in the universe, and we don't know what's causing it. And the dark energy, the stuff that's making us accelerate against the wishes of gravity. Each one of those components creates a curvature of the fabric of space and time, just as prescribed by Einstein's general theory of relativity. If you add those curvatures together, what you find is that they create a universe that is perfectly flat. Flat. Now, that's not the only shape the universe could have had. The universe could have negative curvature, and if it did, that would have we would have a saddle shape. And a negatively curved universe has a net positive energy. The universe is neither a spherical shape, the shape of a ball. That would be positive curvature, having net negative energy. Now, another way to get insight into this is to think about the energy of orbits. An object in orbit is gravitationally bound to what it circles. And bound orbits have negative gravitational energy. That's how we describe this system. Increase the elongation of the orbit by pumping energy, giving more speed to the object, and the circle distorts and becomes an ellipse. Give it even more speed, the ellipse gets more and more elongated. There's just the right amount of energy, just the right amount of extra speed you can give this object so that it goes so far away it never circles back. In fact, it escapes to infinity. At that point, that object and the system and the orbiting object and the object around which it formerly turned has zero total gravitational energy. And that path is formally called a parabola. Give the object even more energy, then it gets to infinity and keeps going. That has net positive energy, and we call that trajectory a hyperbola. Now, you've actually seen these shapes before at home. Take a flashlight. All flashlights have a cone of light that emerges from them. If you take it and aim it straight at a wall, it'll make a perfect circle. Take it and tip the angle just a bit. That circle distorts and you get an ellipse. Tip the flashlight so it's parallel to the wall, and you'll see the shape on the wall, and it'll take the form of a parabola. Angle it a little more, it opens up even further, and you get a hyperbola. Try that at home. So, these are what we call conic sections, intersections of a cone of light. And they relate to orbits, and they relate to the energy that those objects have. Now, if your space-time is flat, just as if your orbit were a parabola, it means the universe, the entire universe, possesses zero net total energy. Think about that. If the shape of the universe were anything else, positively curved or negatively curved, it would not have zero energy. It would have negative energy or positive energy. We have zero net total energy. Now you wonder, is that good or bad? There's a silver lining to this. What it means is that you can create the entire universe out of nothing, because nothing has no net energy associated with it. Had the universe been endowed with either negative or positive energy, we'd be forced to confront the questions of what was the original source of energy that begat the universe. And if it had some amount of energy, why is it that amount and not some other amount? The fact that we live in a zero energy universe bypasses that line of questioning. And does it leave us content in our emptiness? Perhaps. But we're no less enlightened by the ignorance that led to it.